Hi everybody, today we will be working on section 4.6. We'll be graphing polynomial functions. And in order to graph those polynomials, we have to talk about some of the key features. For example, the zeros, the roots or the x-intercepts are all our solutions. They're the places where the graph crosses the x-axis. Okay, and so we get them by setting our factors equal to 0. Okay, remember with our end behavior, there are 4 cases, and they all depend if you have an even or odd degree. Remember, even, they go in the same direction. Odd, they go opposites. Okay, and then a positive or negative leading coefficient. Even means they both go up with a positive leading coefficient or down with a negative. And then odd, they go opposite. If it's positive, it heads in a positive direction, negative direction. Okay. Then finally, this is one we haven't talked about yet. Touching or crossing the x-axis. If you notice that a factor just appears once and it doesn't have an exponent above it, that means it touches. So odd exponent above a factor means it crosses. An even exponent, like x plus 1 squared. Sometimes we've had that where we have the same factor written twice, so we rewrite it as x plus 1 squared. If we have an even exponent, then it just touches. See how at that 0, -1, it goes down and comes back up. It does not cross. Okay? Now here we have an exponent of 3. That's another odd exponent. It crosses the x-axis at -1, right? For all of these, our solution is -1. They just have different degrees, different exponents. And then here, another even exponent means it just touches. So for example, given the graphs below, identify the roots, write the end behavior, and write the function in factored form. So here we have 2 roots. We're just going to estimate that they are -0.5 and positive 1.5. Okay, now because our end behavior goes up, we must have an even degree, and a positive leading coefficient. Okay, so our degree is even, leading coefficient is positive. Now remember, to write our end behavior, I'm going to give myself some space because I didn't see that we were going to write that there. Remember, our end behavior always is f of x and f of x. In this case, both of our ends go up to positive infinity as x goes to negative. X always starts by going to negative and then up to positive. So now my function in factored form, I have a positive number out in front, okay? So I'm not going to put anything. I know my factors will be x and x. To get -5, I had to have, or 0.5, sorry, I had to have positive 0.5. And then to get positive 1.5, it has to be minus 1.5. That's my factored form with a positive leading coefficient. This would have an even degree because if I FOILed it, I would get x times x, which is x squared. There's 2 factors there. That would be my even degree. Okay, now here I have a root at 0, but it just touches the graph. We'll talk about what that means. Okay, that means it has an even exponent when we write it in factored form. I also know x equals 3. Now my end behavior, goes to positive infinity in the front and negative infinity at the end. So my degree must be odd, okay? And my leading coefficient, because I head down, must be negative. So now when I write this in factored form, I know I have x minus 0, let's say, and x minus 3, based on my roots from up here. Now in order to get an odd degree, right now I only have 2 x's. But remember, at x equals 0, my graph just touched. That means I have to have a 2 exponent, an exponent of 2, with that degree of 0, or that solution of 0, so that now I have 2 roots there, 1 here, so that is an odd total number of roots, which makes my degree odd. Okay, then finally number 3, my roots here are at -1, and it just touches there. Sorry. Let's say positive 0.75, and let's say positive 2.5. My end behavior goes up on both. Which means because both ends go together, I must have an even degree and a positive leading coefficient. So now when I write this in factored form, I know I have x plus 1 for this guy. I know I have x minus 0.75 to get positive 0.75. And I know I have x minus 2.5 to get that guy. Now because it just touched, I must have an even exponent at x plus 1. Right now I have an odd number of factors. I have 1, 2, 3. But if I add an exponent of 2 there, that would count twice. So I have 1, 2, 3, 4 total, which makes my degree even. Okay, now we're going to do this, but in the other direction. Here I'm given my function, my polynomial. I need to find the roots. Now if I look at this, I can just factor this. Plus 1 plus 4. So my roots are -1 and -4. Okay, this has an even degree and a positive leading coefficient, so I know both of my ends will go up and up. We don't necessarily have to write the end behavior there all like out exactly like we do usually. So -1 and -1, 2, 3, 4. And I know my ends both have to end up. So I'm going to go down and back up. That's just a rough sketch, but that's based off of those key features. Here I'm going to find the roots by factoring by grouping. If I pull out an x squared, I'm left with x plus 5. Here I'll pull out a -4, I'll be left with x plus 5. Okay, so then I have x squared minus 4 and x plus 5. X squared minus 4 turns into x plus 2, x minus 2, because it's a difference of squares. I can square root it. Then x plus 5. So my roots are -2, positive 2, and -5. Now this has an odd degree, but a positive leading coefficient, so it goes up from left to right. I know I have a 0 at -2, at positive 2, and at -5, 2, 3, 4, 5. Now in order for my first end to be down and my last end to be up, I must go through the x-axis there at -5, then come up, go back down at -2, back through at +2, and end up. Because none of those, when written in factored form, had an even degree, they all cross through. Okay, now here's my last one. My roots, I already have a factored form, so I just have to set these equal to 0. Here, if I add 1, I get 2x equals 1. So x is 1/2. I get -2 there. And +3 here. Okay, the end behavior, this has 1, 2, 3 roots. So it's odd with a positive leading coefficient. There's no negative out in front. This means my graph has a point at -2, +3, and +1/2. Now, if it's odd and positive, they go in opposite directions, climbing, so just like our last one. So it's going to end up, start down, through, and through. Okay, you guys, here is your exit ticket. I'll see you tomorrow when we can go over any of these that you need help with, and I hope you have a great day.